Welcome guys, Mr. Bennett here. Today we'll be looking at the concept of using Newton's second law, and we're going to be looking at the change in momentum and with the situation of a ball hitting a wall. Now there's been one of these sort of questions in an exam for a long time, so I certainly want to show you how this all works. Now if we start with Newton's second law, F equals ma. Now we know acceleration is equal to the change in velocity over the time, isn't it? Alright, so if we start looking over here, we could say that that's equal to mass times by change in velocity over time. So then that becomes equal to simply change in momentum over the time period. So that's what we've got there in terms of the force of the force that's going to be exerted on the wall. Now the key thing with vectors, now we would know that this thing over here is what we call our initial velocity, and that's our final velocity. So v1, v2, or vi and vf. It could also be called our initial momentum, pi. It could be our final momentum, pf. Alright, so whichever way you want to look at that, depending what the question asks. So sometimes it says, what's the change in velocity of the ball as it hits the wall? Sometimes it's talking about the change of the momentum as it hits the wall. So either way, you would have to decide which one you're going to use. We know that change in velocity, or change in momentum, is equal to simply the final momentum, take away the initial momentum. Alright, so that's what we know. If we do that vectorially, what's going to happen there is that our final momentum is basically there. Our minus initial momentum is going to vector going in that direction there. So we know that the change in momentum is always going to be away from the wall. Alright, now if I give you an angle over here, let's say this is actually 30 degrees. Right. And we'll say, let's say it's got a mass of 2 kilograms, and it's moving with a speed of 10 meters per second. Right, so what would be the change in my momentum? Well, we need to work out the initial momentum and final momentum. So we know the momentum P is going to be equal to 2 times by 10, which is 20 sec newtons. So then what we could do is we could put that value into here, 20 sec newtons. Alright, and it's going to be 20 sec newtons because it's going to be identical. We're going to assume it's going to be the concept there. That's 30 degrees to the wall, right? Which makes that, if we're doing there, that's 60 degrees. So that angle is going to be 60 degrees. We can either split this triangle up like that and work out half of that triangle using trigonometry. So if we do that, then we can work out, and we could work out our change of momentum is going to be double that particular side. So that's one way of doing it, and obviously you could use the cosine rule. So you could go, that there is 30 and that there is 30, so therefore you could use the cosine rule to work out the change of momentum. Either way is suitable. So let's use a cosine rule. We can say that the change in momentum is equal to the square root of 20 squared plus 20 squared, take 2 times by 20 times by 20, cosine of 60, and that will give us our change in momentum. So I go to my calculator of 20 squared plus 20 squared, take 2 times 20 times 20 times cosine of 60, enter, and that gives me an answer of 20. Alright, so go back to my thing, so that's actually 20 sec newtons, alright, away from wall. Now you might have identified that as actually an equilateral triangle. Alright, that's 60 and that's 60, and that's going to be 60. So if you can identify that, then you actually don't have to do the calculation. But if you don't, you do the calculation and you go, oh, it's an equilateral triangle. Now, that's the first part of the questions, either to work out the change in velocity or change in momentum. Quite often they also ask for the other bit, which is the what the force is, and we know the force is the change in momentum over time. So the force is equal to the change in momentum over the time. Let's say this has an impact with the wall for 0.1 of a second, 0.1 of a second, then that's going to be equal to 200 newtons. Okay, so in that particular time period, it's going to exert a force of 200 newtons. As I said before, this is a very typical sort of question that you'll find in an exam. And it will ask you either to find the momentum or the change in velocity, and we're using the vector addition. Okay, for that, it's really important that you get that concept. All right, so make sure you try a number of these types of questions. Having problems, make sure you come and catch up with me and go through them with you.